going to be continuing with identifying patterns and making rules for our linear functions. There has been a lot of questions about this, so I am taking a moment and give a great opportunity to look it over again and kind of discuss it, and also change the worksheet to hopefully best help you represent your thinking a little bit easier. So many of us touched on this before. Period 1, 4, and 7 had a pattern making it clear. My other students have been working on this a little bit longer, so actually this is a weird time of year when all my algebra classes are in the exact same place. So this is actually really exciting. That means the end of the year is winding down as it should be. So looking at identify patterns and making rules for our linear functions, let's review some of our terminology. So a function equation is an equation where every input has one output. So it's another way to say every x has a y and every domain, has a range. A linear equation we've been working with all year. Sometimes we didn't really mention what it was. It's just a line. Linear equation is y equals mx plus b. An equation which creates a line due to the constant rate of change, which is another way to say the m stays the same. So we're working with functional linear equations, which means our y turns into f of x because it actually means the same thing. It is the function of this x, or the output of this x, because we put the x into the machine and it pops out the y or the f of x. So again, this is our guiding linear equation. F of x equals mx plus b, m being the slope and b being the b constant. Y-intercept, excuse me. So let's look at these steps again. So the first thing you want to do is examine the input and the output. So that's the left column is the input and the right column is always the output, the x and the y. Asking yourself, how did the input turn into the output? Now this could be any operation, addition, subtraction, multiplication, or division. We're only going to be working on addition, subtraction, and multiplication today just because division's been a nightmare for you guys to write, so we're not really going to stress it. And we're only working on one operation. Normally, if you look at your linear equation, we have mx, which means multiplication, and a addition sign. So there will always be two, not always, there's two operations often in linear equations, but we're only going to be working one at a time. So you've looked at your input and your output, and you should see some sort of pattern forming. Now, this could be a pattern that is proven right or is proven wrong. The point of it is to make sure that it works with each pairing. So this is when we work horizontally. I will be doing one or two with you to show you how I do my thing. If it works for each pairing, then you get to write the rule. Now the rule is just another way to say the equation. The function equation is the rule of that function. So we'd write f of x. If it is multiplying, we'd write the number it's multiplying by x. And if it's adding or subtraction, we'd just write it down at the end. And I think that's one of the confusions. So I'm going to be going through examples of all of them. Practice is the next page. I tried to do much better with spacing this time because it's been doing crazy things. So we have to examine the in and out table. We're going to go through the steps and we'll write what was done. That's a silly direction. Write it out in terms of x and y, f of x. So we're really pushing f of x as our y for this one. I'm going to show you. So this is how I set it up a little bit differently. We have the inputs and then we have the outputs. And I'm going to ask you to show the work, and I'll show you right now what I mean by showing the work. So we went from 2 to 4, went from 3 to 5, 4 to 7, and 5 to 9. Doesn't make sense. One second. Miss Hanley made a mistake. Yes, Miss Hanley made a mistake. Miss Hanley fixes her mistakes in real time. Okay. Now we're good. I also want to apologize if you can hear my dog snoring in the background. All right, so we have 2 to 4, 3 to 5, 4 to 6, and 5 to 7, now that Miss Hanley took out her mistake. So some of you are very good at pattern finding. You already see a pattern. Others of you, it takes a couple tries, and there's nothing absolutely wrong with that. So I went from 4 to 6. Well, what could get me to 4 to 6? You can't multiply anything you get to 4 to 6. Can't subtract because 4 is growing. So it must be addition. What would I have to add to 4 to get to 6? Well, I would have to add 2 to get to 6. So now I would have to check and make sure that worked for every single one. Now I chose 4 and 6 totally at random. Some numbers are a little easier to work for. We're going to discuss zeros in a second. But I just started here. Just because I started at 4 to 6 doesn't mean I know my equation just yet. I have to kind of like go through and check. So I'm going to start at the top. I have 2 plus 2, and that equals 4. That works out. 3 plus 2 equals 5. Also works out. And 5 plus 2 equals 7. So it works out. Now I have to write this into equation. Now I know that we're going to start with the f of x, and that equals. I did something to the x, so let's put the x down. And what did I do to the x? I added 2. And that's the equation. F of x equals x plus 2. The y will equal whatever x is added to. Make sense? If you ever have questions, please never hesitate to email me or comment in the classwork. I do try to get back to you as soon as possible. So now let's look at question 2. I'm going to just leave you with a possible. So we have 2 to negative 1, 3 to 0, 4 to 1, and 5 to 2. Now, I mentioned zeros in question 1. Zeros are actually, to me, make things a little bit easier. So we have 3 to 0. Well, there's 2 things that I immediately think of that would make 3 equal 0. 1, 3 times 0 would equal 0. But also, we would have 3 minus 3 would also equal 0. So I have 2 possibilities here that I'm going to have you guys actually figure out which one would work. So this is one of those cases where I said it's best you have to try every single one of those pairs because only one of these is actually going to work. Let's move on to question 3 now. I'm going to do kind of similar with question 3. Now, I have a negative 1 to a negative 5, a 0 to a 0, a 1 to a 5, and a 2 to a 10. I have very few ideas. So we have 1 to a 5. I'm going to start again, totally random at 1 to a 5. Now, to get 1 to a 5, I could add 4, and that would equal. Or I could also times it. I know we say never use X's, but Google Docs. Oops, I meant to take out this space because I have OCD. Okay, so these 2 are also possibilities. So I'm going to ask you to look through and determine which one works. Number 4. So I'm going to tell you ahead of time. One so far has been addition, one's been subtraction, one's been multiplication. Number 4, it could be anything. I'm actually not going to go over this with you at all. I think you got it, and I want you to think about it very, very carefully. So we have 5 to a negative 5, 6 to a negative 6, 7 to a negative 7, and 8 to a negative 8. You guys got this. I believe in you. I look forward to grading your work. Again, always email or comment, and then I'll try to get back to you as soon as possible. Take care.